Hello everyone, welcome to next round coding. Today we're going to solve LeetCode 4012 count of unfinished tasks after each shift. So first of all we understand the problem, then the approach behind this problem, and then we will code it in C++. So let's go. So the problem states that there is a task array and there is a shift array, and they are not necessarily to be the same size. Now in the shifts we have 20 units. So in 20 units time, how many works or tasks we can complete over here? So it is 2, 4, 3, 2. So if we sum it up, it would be 8 plus 5, 13. Now 13 is lesser than 20. So in 20 units of shift, these 4 tasks will be completed, right? So there is no remaining task after this shift, right? So there is 0 remaining task after this first shift. Okay. Now next shift is of unit 5. Now in 5 unit time, we can complete the first task and there will be remaining 3 units. In 3 unit time, we can't complete the second task because there will be 1 unit task will be remaining, right? So after the second shift, there will be 3 tasks pending. So the answer will be here 3. Now for the next shift of unit 6. So in unit 6, as you know, we have previously 1 unit left from the previous shift. Now this will be added. So 1 unit, then 3 unit, then 2 unit. If we sum it up, it would be 6. So if it is 6 and our shift unit is also 6, so there is no tasks remaining after the third shift. So it is again 0. And this will be our answer. We just need to return this answer. So this is the question. I hope the question is clear to you. Now let's move on to the approach. Okay, so let's take 2 variables. One is our current, which is denoting the current task index, and one is completed, which will denote how much work is done on this current task. Okay, so in the first step we have 8 unit time, right? And our current index task is 0, means the first one. So we have 8 unit time and we need to check the sums of this task, which gives us the sum lesser than equal to 8. Means we need to find the index over here that will give us the sum of the task which is lesser than equal to 8. So for this case, if we sum it up these two, it will give us 5. And if we increase this range to this, then it will be 9, right? So we can't exceed 8. So for this case, we just can go to this range. So if we can go to this range, then these works will be completed in this shift time, and the remaining work will be pending, right? So our current index pointer will be pointing to these 2 are done. Then the next one means this one, means it would be 0, 1, 2. So the parent index will be 2. And for completed, we have 8 unit time in the shift. We have worked for 5 units. 2 plus 3 is 5. Then 3 unit time is remaining, right? So in the 4 unit task, the 3 unit goes off, so it will be 1, right? So the completed will be 3 unit, right? Now the remaining tasks over here is 1, 2, 3, 4, 5. So 5 over here. Now go to the next shift. The next shift is 4. Again, our current index is this one. Now we need to check the sum over here, which gives us the sum lesser than equal to 4. So if we extend the range, this is 1, this is 2. Now when go to this, 2 plus 5 is 7. So we can't go to this. We need to go to this, right? So this will be the index 3, 4, 5, 6. So till index 3, our work will be completed with the second shift. So our current index will be now at index 4. And how much work will be completed in the index 4? Two unit work is done, and we have 4 units. So 4 minus 2 means 2 unit work will be also done here. So completed will be 2, and remaining here will be 3, right? And number of pending works for after this shift will be 1, 2, 3. So it will be 3, right? Same way for the next shift. The next shift is 2, and our current index pointer at 4. If you see here, the task size is 3 and the shift time is 2. So we can't complete the whole task over here, right? So for this case, the remaining tasks will be 1, 2, 3, and we are still in the current index, and completed will be just 2 plus 2 is 4. So 4 unit work will be done over here, and remaining would be now 1, right? Same again for 2. Our current index is now 4, and here is 1, right? So we just extend our range. When it is 1, it is good. When it goes to 2, the sum now is 3, but we have only 2. So we can go only for this range, the 1, right? So when we go to 1, our current index will be now at 5, and completed will be now 100 will be left because we have 2. So completed will be now 1, and we just update over here is as 1 and 2, so it will be 2. And this will be our answer because there is no shift left over here. Now the question is that how you will check this range. If you are able to check this range, then our job will be done. We can check this range using the binary search and the prefix sum of this task array. We will do just the prefix sum of this task array, and as we have the current index, suppose we have done this prefix sum of this array. Okay, this prefix sum is done over here. Now we have standing at this position. Our current index would suppose are standing at this position. Now, so we have a range of L at this and R would be at this. Now we just start the mid. When you start the mid, the prefix sum of mid minus the prefix sum of our current will give us the sum of this portion, right? And also we have some completed work as well. So the prefix sum of current minus completed is our remaining work for this task, right? Now when this total value is lesser than our shift size, I'm naming as a total, okay? When the total value is lesser than our shift size, shift of any position, I am naming as I, then we can extend our range. So we can just extend our mid in this range. So we can do just L equal to mid plus 1, right? Or if the total is greater than our shift size, then we need to shrink our range, right? Then our R will be mid minus 1. This way, using the binary search and the prefix sum, we can get this range, and then we will compute our current index and completed part. And after computing this, using the current index position, we can decide our answer factor, right? And this will be total lesser than equal to 6 for the L condition, because if it is equal to, then we can also try to extend it. Okay, so using prefix sum and binary sort, we can compute this. Now let's see the code and try to get it in better way. Okay, now let's see the code. So let's compute the size, docs.size, and our aim as shift.size. As I told you, we need to do the prefix sum. So let's build our prefix sum array. Do it long because the integer are long or is a big integer. You can see the 9. So 9 to 5 not set in integer. That's why we use long. Prefix array of size n. Prefix of 0 as tops of 0. Now compute prefix sums. P of I minus 1 plus task of I. This is done. Now we need our current index, right? This is 0 and our completed at 0. Now we need to build a function. So let's build a function. I am building a lambda function over here, which will pass our shift time. So this is our shift time. Our L would be our current, and our R would be n minus 1, and our result would be initially at current. So now do the binary search. Less than equal to R. Compute the mid L plus R by 2. Now, as I named TOT, total would be our prefix sum of mid minus prefix sum of current plus task of current minus completed, right? This is done. Now if our TOT is lesser than equal to shift, then we just update our result as made and L and plus 1 and R as made minus 1. Okay, at the end we just return our result, and here is the column. Now let's iterate over the shift. Boolean. Now our remaining is our task of current minus completed, right? If our remaining is greater than shift, then our completed will plus equal to our shift, because there will no task will be completed in this shift. Shift of I. There will be also shift of I. And our n script, we need to build our n script now. So ns of I will be n minus our current, right? Or we just continue, right? Great. Now our new current index will be function of our shift, right? If this new current index is equal to our n minus 1, means we have finished all the tasks in this shift, then we just reset it. So our current index will be at 0, completed at 0, and ns of I is also 0, and we just continue, right? And then if the remaining part means int required is prefix of current. First of all, the prefix of new current minus prefix of current plus our task of current plus minus, sorry, completed. This is done. Now the completed will be now for the next part will be our shift of I minus required, right? And our current will be new current, right? And ns I will be now n minus current, right? And that's all. At the end, we just return our else. I hope this code looks good. Let's try to run it and see. So there is some errors. I hope it's long. Oh, my bad. There will be a size of wave, and current will be new current plus 1. Now it's looks good. I'll try to run it. Yeah, you can see it's running fine. And just for overflow, I am just using it as a long. And also I am repeating it as a long. And I hope all things are look good. So minutes now, just submit it. As you can see, it is accepted. Now talk about the time and space complexity. So the time complexity over is m into log of n, because the shift size is of m, and log n for this binary search over the task array. So this will be our time complexity, big O of n into log of n. And our space complexity will be big O of n, because we are storing our prefix sum array of size n. So that's why the space complexity would be big of n. So I hope this solution is clear to you. And if you have any doubt, you can comment me out. And please do like and subscribe. Thank you.